Thank you very much. It's my pleasure to be here and to get to share some of my enthusiasm for dermatology with all of you. As you can see from how I've spent my professional time, I have been committed to academics, and in academics people get to do a lot of different jobs, including teaching, patient care, research, and a lot of administration work. And I think that can be a little bit hard to find the right balance, but one of the most wonderful parts of it has been having wonderful research colleagues that have allowed me to continue to follow my passion, which is research. I have wanted to do biological research since I was in third grade and put iodine on potatoes to prove that they had starch in them. So that's what has always been my goal, and why I went to medical school and why I chose dermatology was because dermatology was a wide open field for basic science research. And I was lucky enough to be in association with colleagues who maintained a relationship in our research throughout my time, and one of them is with me tonight, Dr. Peter Song, at the table there, we've worked together for 18 years. So he started working with me when I was at Emory University, and with one of our other colleagues, Dr. John Ansell, who the three of us were recruited here to UAMS in 2008. Unfortunately, Dr. Ansell passed away with cancer about a year after we arrived here. So Peter and I are working hard to carry on our research activities, and I obviously have a lot of administrative and patient care duties that I'm fortunate enough to be able to do as well. But research can't be done without a team, and it's really, really wonderful to find a team that can stay together for as long as our team has. And I'm glad I can thank Peter publicly tonight for all that he does to keep our research going. And it really ties into the topic tonight, because basic science researchers in dermatology are the people who are really trying to understand how the cells work. How do keratinocytes work? Those are those cells in the top layer of the skin. How do melanocytes work? Those are interwoven in the top layer of skin called the epidermis with the keratinocytes, and they make the pigment in our skin. Then there are antigen-presenting cells in the epidermis, and underneath the epidermis in the dermis of the skin are fibroblasts, and fibroblasts are really the workhorse of the skin, and they're poorly appreciated, I think, because they do a lot of work when people are young and growing and the skin is expanding, and then they don't do much. But they make the collagen that makes our skin look good, and we're beginning to realize that when that collagen starts to break down from sun damage and from just reactive oxygen damage that happens over time, those fibroblasts don't work as well. They stop producing collagen. They actually start making an enzyme that breaks down collagen, and the skin starts to look old, wrinkled, saggy, and we don't like that as much. People like the healthy, young-looking skin. So the basic science that has been done to understand how these cells work has really allowed a lot of work to be done by cosmetic companies and pharmaceutical companies that sell cosmetic products. And some of the products are therapeutic products, so they can be used for skin diseases. So then they may be both cosmetic and therapeutic. So there's a lot of overlap between things, but the science of beauty is really, I think, the foundation of it has been established by basic cutaneous dermatology researchers, both PhDs and MD researchers, over the last 50 years at least, when we were able to start growing these cells in the lab and really starting to understand their function. So I will be able to answer questions about some basic aspects of skin biology, as well as skin diseases and interactions with dermatologists and cosmetic companies as we get into our discussion section.